Hello students and welcome back to my channel. Today I am here to discuss questions based on mechanics which were asked on the 1st of February 2023 JEE Mains. Okay. So without wasting time we can see that question 6, a block of mass 5 kg is placed at rest on a table of rough surface. Now if a force of 30 Newton is applied in the direction parallel to the surface of the table, the block slides to a distance of 50 meters in a diameter of 10 seconds. Coefficient of friction we have to find. Of course, there is no discrimination between static and kinetic. Okay, so both are one and same, and this simply you can take it as mu. So draw the free body diagram, students. It's a very simple question. Let us say F is the force, applied force, which is 30 Newton here. Okay, weight will be 5 into G, that is 50 Newton mg. Normal reaction will be vertically up, I'll take N, and friction will be opposing the motion. Hence friction you can take it as F in this direction. Remember, the block is already moving. So the block is moving means we have to take kinetic friction, and kinetic friction is always mu into N. Okay. Now you can see, since the block is moving horizontally, vertically it will be in equilibrium. So considering the vertical equilibrium, we can write normal reaction is equal to 50 Newton. Okay. So therefore force of friction will be mu into 50. Now if we apply Newton's second law along the direction of motion, then we have Newton's second law as force is equal to mass into acceleration. So net force towards the direction of applied force is 30 minus 50 mu is equal to mass, which is 5 kg, into acceleration. Okay. Acceleration we can find, for now let us write it as we can find the acceleration this way. See, initial velocity is 0. Okay. And the displacement is 50 meters. And it happens in time 10 seconds. We have to find A. So we can be using the formula S equal to ut plus half at square. Remember, acceleration is constant because forces are constant. So you are supposed to use this equation of motion only if the forces are constant or acceleration is constant. So we have 50 is equal to 0 plus half A into t square. So exactly A is 1 meters per second square. Okay. So this will be 5. So therefore we have 50 mu is equal to 25. So mu is equal to half, that is 0.5. Moving to the next question. A small particle moves to a position distant from its initial position under the action of the value of work. You can see that force is constant. So simply you can obtain work as the dot product between force and the displacement vector. Okay. So work done is simply the dot product of force and displacement. So force vector is how much? 5i cap plus 2j cap plus 7k cap. And displacement is, you can see this is the initial position, this is the final position. You know that displacement vector is position vector of final point minus position vector of initial point. Okay. So what is position vector? Position vector of final point is this, whereas position vector of initial point is this. So from final you will deduct initial. Okay. So 5i minus 2i is 3i cap. Then minus 2j minus 3j is minus 5j cap. And plus k cap minus of minus 4k cap is 5k cap. So you know how to calculate the dot product. Multiply the coefficients of I cap together, then coefficients of j cap together, and then coefficients of k cap together. So we'll get the result. So 15 plus 35 is 50 minus 10. So this will be 40 joule. 40 joule is the answer. Moving to the next question. As shown in the figure, a block of mass 10 kg is lying on a horizontal table. You can see the figure, students. It is pulled by horizontal by a force F, making an angle at 30 degrees to the horizontal. For mu s equal to this, the block will start to move for the value. So in the limiting condition, they are asking to find the value of F. In the limiting condition means it is on the verge of equilibrium. So now the first step will be, students, to draw the free body diagram and ensure that all the forces are resolved in the direction of movement and perpendicular to it. So the direction of movement here, it is not, the block is not moving. So in that case, you can take any two mutually perpendicular directions to resolve. Okay. So here I'll take this friction in this direction. I am taking horizontal and vertical directions. So this where we have F cos 30 degrees and F sin 30 degree, and there will be normal reaction. So this is how we have resolved. Now since the block is on the verge of motion, we can use frictional force equal to mu into F. So we have to find mu. So in order to know mu, we have to consider the vertical equilibrium. So for vertical equilibrium, we can write N plus F by 2 is equal to 100. So the normal reaction is 100 minus F by 2. Now, since it is on the verge of movement, we can say that the force towards right must be just balanced by the force towards left. So based on that concept, we can say that F root 3 by 2 is equal to mu into N. So N is how much? N is 100 minus F by 2. Now let us divide both sides by, let us multiply both sides by 2. So we have F root 3 is equal to 200 mu. We have to keep mu like this only. So mu is given 1 by 4. I'm sorry. Mu is given as 1 by 4. So I'll write the value of mu here. 1 by 4 minus F by 4. Remember, I have already multiplied by 2 here. Okay. So we have F into root 3 is 1.732. 0.4 is 1 by 4 is 0.25 is equal to 50. So F into this will be 1.982, okay, which approximately can be taken as 2. So friction force is 50 by 2, which is around 25 Newton. So B option is the correct option. I hope that is clear. Then moving to the next question, figures A, B, C, D show variation of force with time. Impulse is highest. Now students, we know impulse is the effect of force, okay, effect of force for whatever interval it is acting. So basically it is measured as the product of force into time interval, and this will be area below the force time graph, area below the force time graph, okay, area below the force time graph. So here you have to find the areas individually and you have to check whichever has the highest area, that will give us the answer. So here you can see area is half base into altitude. Here area is length into breadth. So this is 1 by 4, this is 1. Here area will be half base into altitude, and here it is half base into altitude. Okay, so you can see the largest area is this, case B. So figure B shows the situation in which the impulse is highest. Then moving to the next question, a block is fastened to a horizontal spring. The block is pulled to a distance x equal to 10 cm from its equilibrium position at x equal to 0 on a frictionless surface from rest. The energy of the block at x equal to 5 cm is. So it is like this. Suppose this is the situation in which the block is at rest here. Okay. Now it is compressed to a distance 10 cm. Pulled by a distance 10 cm from this is the equilibrium position. And then the energy of the block when x is equal to 5 cm. So when the block is somewhere here, probably we have to, I'll draw it in another diagram so that things are clear. So here the block is at rest. Okay. So we have to find the energy here. Here, this question is based on law of conservation of mechanical energy. The spring block system represents conservative force field. Here, the total mechanical energy will remain conserved. So, what is the total energy? Here, the total energy is only the elastic potential energy of the spring. Whereas here, the spring is not fully relaxed, so a part of energy will be there in the spring in the form of elastic potential energy. And also the block is in motion, so there will be certain energy in this. So now what we can do is that we can find the total energy. So total energy, I'll take it as E, is simply half K into 10 centimeters square. This is the total energy. Okay. Then here the energy of the spring will be total energy minus, the energy of the block will be total energy minus energy of the spring. Here what is the energy of the spring? You can see that the energy of the spring is half K into 5 centimeters square. So this is the total energy. Out of total energy, if you deduct the energy of the spring, you will get energy of the block. So energy of the block is total energy minus energy of the spring, which is actually given as 0.25 joules. Okay. So from this equation, we can find the result. So total energy is half K into 10 centimeters square, which is equal to, from that you deduct energy of spring here. Energy of the spring is half K into 5 centimeters square. So this should give you 1.1/4.25. So I'll take K by 2 common. Also centimeter to be converted into meter. Okay. You have this. Now I have converted everything in SI units. So we have 2 2s are 4. So therefore K will be equal to 10 power minus 4 goes that side, becomes 10 power plus 4. This is 10 minus 5 is 5 into 10 plus 5 is 15. And remember this 2 is left there. Okay. So 5 2s are 10, 1 0 gets cancelled. 5 3s are 5 2s are. So finally we have 200 by 3, which is 66.67. Now students, this is an integer type question. And if you come across these kind of questions, you are simply supposed to round it off to the nearest integers. Okay. So 66.67 rounded off to the nearest integer is 67. So 67 is the correct answer. Don't get baffled and don't get confused. In certain cases, you might get results which are not purely integers. So simply round it off to the nearest integer. Then moving to the next question. A force F equal to this much acts on a particle in the y direction. You can see force is variable force. It depends on y. So where F is in Newton and y is in meter. The work done by the force during displacement is, so the displacement is along the direction of y. So simply we can write force is equal to the summation of elementary work done during elementary displacement. So elementary work done will be force into dot product of this force and dy, where y varies from 2 to 5. So this will be 5 plus 3y square into dy. Okay, integrated with limits 2 to 5. So we have 5 into y plus y cube, integrated with limits 0 to 5. So therefore we have 5 into 5 minus 0, upper limit minus lower limit, minus 125 minus 0. So 25 plus 125 is, sorry, I'm sorry, this is 2. Lower limit is 2. So this will be 2. So 5 3 is a 15 plus 125 minus 8. So 140 minus 8, that is 132 joules. So 132 is the correct answer. Okay. That's all students in this channel, in this YouTube. Thank you. This video.